Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about the general power rule in integrals, right? So we're going to be talking about the general power rule in integration, right? So let's go ahead and get started. So what I'm going to do is I'm going to start with the derivation of a function here, right? So let's suppose if I have a function, let's say of this nature, that is ax plus b raised to the power n plus 1 divided by a into n plus 1. Now if I want to find the derivative of that function with respect to x, so what is going to happen? First of all, this n plus 1 will come out. That means I'll have n plus 1. Then what is going to happen is that I'm going to be differentiating this whole function. So that means I'll be differentiating this whole function. That means it's going to be a, and then I'll have the function itself, which is ax plus b, divided by a into n plus 1. So as you can see, this and this will get completely eliminated, and I'll be left with ax plus b, which means that I'll be left with n plus 1 minus 1. I'm sorry about that. So we'll be left with ax plus b raised to the power n, because in differentiation we reduce the power by 1 unit, right? So that's what it is. So that means the differentiation of this function is this. That means the integration of this function is going to be this, which means I can say that the integration of ax plus b raised to the power n is actually equal to this one over here, that is 1 over a into n plus 1 into ax plus b raised to the power n plus 1, which is actually this. So that means I can say that the integration of ax plus b raised to the power n is equal to 1 over n plus 1 into ax plus b raised to the power n plus 1. As you know that the differentiation of this function is actually equal to this, and the integration of this function is actually equal to this. And this is only possible when n is not equal to negative 1. Fine. So suppose you're understanding this point over here. This is only possible when n is not equal to negative 1. But what if I say that the value of n is equal to negative 1? Let's suppose 1 over ax plus b dot dx is my integral. So then what will I do? So then I'll do 1 over a, that is because of this 1 over a, ax, into log to the base e of ax plus b plus c. So remember, you don't have to forget the constant. Never forget the constant. So add the c here, right? So that means if x is equal to if the value of n is equal to negative 1, then this is what your function is going to be. And if I kind of go ahead and differentiate this, if I go ahead and differentiate, let's suppose this is f of x. If I go ahead and differentiate f of x, I'll be actually getting this value. So if you want to check that, let's see. So I'll have 1 over a into the differentiation of ax plus b, which is a, into the differentiation of log, which is 1 over ax plus b, right? And the differentiation of the function is of a constant is always 0. So that is actually going to give me 1 over ax plus b, which is actually going to be this. So suppose you're getting what I'm trying to say here, guys. So that means I can say that the first point is that the integration of ax plus b raised to the power n dot dx is actually going to be equal to 1 over a into n plus 1 into ax plus b raised to the power n plus 1 plus c. And the second point is that the integration of 1 over ax plus b dot dx is actually going to be equal to 1 over a into log of ax plus b to the base e plus c. So these are the two rules, general power rules, which are important here. Now let's go ahead and try some questions out here, right? So let's go ahead and do that. So the first question that I like to try is find the antiderivative of 3x plus 7 raised to the power 4. So how I'm going to do that? So that is actually going to be equal to 1 over a, that is 1 over 3, into n plus 1, which is 4 plus 1, into 3x plus 7 raised to the power 4 plus 1 plus c. So that is actually going to be 1 over 15 into 3x plus 7 raised to the power 5 plus c. Fine. So I've just used the formula and just put everything in the formula, and everything worked out well. Let's go ahead and try another one. So let's try another one. So let's say I want to try the antiderivative of 3 into 4 minus 2x raised to the power 5. So first of all, this 3 is actually going to be completely out, so this 3 is going to be here. Then I'm going to finding out the integral here. So I'll have to take care of this negative 2, which is actually going to come out. So I'm going to say 1 over negative 2. Then I'll have to take care of this 5, so that means that can be taken off as 5 plus 1. And then it's going to be 4 minus 2x raised to the power 6. Right, so plus the constant. So that means it's going to be 3 over negative 3 over 2 times 6 into 4 minus 2x raised to the power 6 plus c. And now it's just a matter of calculation. So it's 4 minus 2x raised to the power 6 over negative 4 plus c. Right, so I suppose you're getting this point over here, guys. Let's try one more. Let's say I want to find out the integral of 4 over 2 minus 3x raised to the power 2. So that can actually be written as 4 into 2 minus 3x raised to the power negative 2 dot dx. Again, the same stuff that I'm going to do is I'm going to find out this 4 is going to be here. I'll have to take care of this negative 3, so I'll be minus 1 over negative 3. I'll have to take care of this negative 2, that is negative 2 plus 1, into 2 minus 3x negative 2 positive 1 plus c. So this is going to be the antiderivative of this function here. So suppose you're getting this point over here, guys. So if even if I want to try out the antiderivative of, let's say, of sine 4x. So let's suppose I want to find out sine 4x. So what is going to be, first of all, I'll actually take care of the 4x. So if I want to take care of the 4x, so what will I have to do is I'll have to divide by 4, and then the antiderivative of sine of 4x, which is going to be negative cosine of 4x plus c. Right, so first you take care of the inner part and then you go outside. So this is how you keep going. Right, so let's suppose if you want to find out the antiderivative of secant square 3x. Right, so first what you do is you take care of the 3x. So that's going to be 1 over 3, and then you take care of the secant square 3x, which is going to be tangent 3x plus c. Fine. So I suppose you're getting this point over here, guys, and you're understanding what I'm trying to explain. Right, so thank you very much for watching this video, guys. In the next video, we're going to be talking about some circular trigonometric functions. Right, so that'll be it, guys. Thank you very much for watching. This is our website address to explore more about us. This would be our Facebook page to give us your valuable like, and this would be our email address to give us your valuable feedback. So thank you very much for watching, guys. I'll see you in the next